Assalamu alaikum students. Now today we have to read about the dual nature of light. By dual, that means having the two natures. Right now, what we are reading that the light is having a particle nature as well as a wave. Particle, that is, light behaves as a particle as well as wave. But these two natures are not fixed for the light. Actually, whatever are the effects before us right now, whatever effects of light are going to be found, those are either explained by consider light as a particle or light as a wave. As it has been found that light has dual natures, that is the wave as well as the particle nature. The phenomena like, if you are going to take phenomena like which falls in the wave category, that is interference, you are having diffraction, we can explain them well by considering wave. Light is the wave. Now, if we consider light as a particle, then we can explain the photoelectric effect, which we have read. Photoelectric effect. We can explain Compton effect. So these very effects are well explained by consider light as a wave. And if we have to answer the interference diffraction which we are going to study in light, then we have to consider light as a wave. So actually light is not having a fixed nature depending upon the, what I mean to say, effect. Its nature gets changed like that. So depending upon the nature of experiment, light behaves as a wave as well as a particle. Now particle nature of wave, light as having a particle nature, so it travels in space and carries energy in discrete packets known as quantas. So once we will see that it travels in the form of what I called as the photons. That light travels in the form of fixed energy packets known as quanta or photon. And each photon is having an energy E equals to n h nu, where nu is the frequency, h is the Planck's constant, and n is simply the number 1, 2, 3, 4. That light travels in the form of photon. Therefore, and energy of each photon is actually E is equal to n h nu, where n is the number for 1, it's for n equals to 1, comma 2, comma 3, comma dash 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 dash. But we can also put it like this. We are having C equals to nu into lambda, or which implies nu equals to C by lambda. Therefore, E equals to what simply, for leaving n, it is simply H into C by lambda. This is how we are going to find the energy of the photon. So, for as now we have to understand that in dual nature, what we have to understand that light is having the dual nature, but it depends upon the effect. For sure, it depends upon the effect. I'm saying that the dual nature of light is not fixed. Tomorrow, if some different aspect is observation, some different effect is going to found, which is neither explained by particle nature nor as wave nature. Maybe there might be some different nature of light. But right now, whatever are the effects, those are well explained by some effects by considering light as a particle. So in that very particle, we have to take it as a photon, which is having a fixed energy, and its energy E is equal to n h nu. And if we have to consider the wave, then we can answer the effects like interference, diffraction. We are going to study them in light. Now, photon is a quantum of energy which has zero rest mass. This photon is having a zero rest mass. Zero rest mass. By zero rest mass, that means it doesn't come to rest. And it is, if you are going to find out what its energy, then its energy is equal to the product of Planck's constant and frequency of the light. This photon, which it always always travels with speed of light, has a zero rest mass, that it doesn't come to rest, always travels with the speed of light. That is how much? That is 3 into 10 raised power 8 meter per second, which we have to remember. Then if we are going to take some another property, some property that photon travels in straight lines. Travels in straight lines. Or this photon, it is not, it is not deflected, deflected by electric or magnetic fields. And you have to remember that energy of photon does not change, does not change as it goes from one medium to another medium. So as I told you that rest mass of photon is zero, you can take it from here also, that we know that mass of a particle moving with velocity v. If we are having a particle which is having a velocity v, then its mass, which is called as the relativistic mass, equals to 1 by under root of 1 minus v square by c square, where m naught is the rest mass. Rest mass. For photon, v equals to c. Therefore, m naught is equal to m into under root of 1 minus v square by c square is equal to, for photon, m into under root of 1 minus c square by c square. C square by c square, that's 1. If this is 1, 1 minus 1, that is 0, that m naught is equal to 0. That's how we are going to say for a particle which is at rest rate, for a photon, we're having rest mass as 0 as it doesn't come to rest. So these were some properties. This was some simple nature related to light. Tomorrow will be at another lecture. Till then, Allah Hafiz.